we're picking up from question number 13. We're going to go to question number 14. This is part 3 of our Algebra 2 1 through 80 quarterfinal review, picking up with question number 14. I gave you guys a list before we started video number 1, right, of questions that were on the review that you wanted to be able to look at. Was 14 on that list? Yes, it was. Okay, so this says factor the expression, and our expression is x cubed minus 3x squared minus 100x plus 300. Okay, how many factors are there going to be as we look at this? I should already know how many factors there are going to be. Does anybody know? There's going to be 3 factors, right? How do I know that? The exponent. The largest exponent is 3. Okay? All right. So as we want to begin breaking this thing down, can we, what's the first thing that we want to try with something to the third? Factor by what? Factor by period? By pairing? Yeah, I think you're just using a different term than factor by grouping, right? Okay, so let's look at this section right here. What can I factor out of that first group? X squared. Just going to leave me what? X minus 3. Okay, what can I factor out of that? Negative 3? Negative 300. Negative 100. Okay, I hear a lot of things all at the same time. So that's going to leave me with x what? Minus 3, right? Which is great. That's what I'm looking for. If I don't get the same thing, I know that I can't factor by grouping. If this had come out as like x minus 4 or something, we'd know that doesn't work. All right, so how can I rewrite this? X squared minus 100 times what? X minus 3. So I have 2 factors, right? Okay, but we established at the beginning, how many factors do I need? 3. So I have a problem. I don't have enough factors. Is there something that can be factored down? What is it? X squared minus 100. Okay, so I know I'm going to end up with x minus 3 as part of my solution. What do I need to do with x squared minus 100? What's that? Factor it. Okay, do we notice anything unique about it? It's a negative, or it's, I'm subtracting a perfect square, right? And notice that there's no just x value there, correct? So what is x squared minus 100 going to look like whenever I factor it? X minus 10, x plus 10. So it's going to be a sum difference, and that's going to explain why I have an x squared but no just x value, right? X minus 3. How many factors do I have there? Can I factor anything further down? No, that's my answer. Okay? Now, if this is a multiple choice question, it may not look exactly like this. So this was what, question number 14. I want to look at the test and see what this matches up with to see if it's a good match. I'm looking at the wrong thing here. Let's take a look, see what 14. Okay. So on the test, it's going to be a little different. Okay? It's going to be, it's going to give you a binomial, which is going to be something x cubed plus something x squared plus something x plus something. And it's going to say which binomial is a factor. And looking at this, I believe that you can solve this by grouping. Okay, you should be able to find it. Okay, does that make sense? All right, it's going to say which one. All right, so you should be pretty good on that one. I think that's a pretty good matchup. If they're not good matchups, what I've been doing is trying to solve a question from the review, but then make up a question that's a little closer to the question on the test to help you out. Okay, number 15, is 15 on the list? Yes or no? No? Okay. Let me look through the test and see if I might be missing something. where I think that might actually work. It actually fits in slightly with like a question number 5 on the test. We're going to go ahead and solve number 15, just in case it might help you somewhere. Negative 2x plus 4 minus 3 equals negative 1. If we wanted to solve for x in this case, what's the first thing I'd want to do there? Add 3. We want to isolate the radical. All right, so you're absolutely right. We would add 3. So we would get the square root of negative 2x plus 4 equals what? 2. All right? What would I do from there? If I'm trying to solve for x, I need to get rid of as much as I can. Not square root both sides. Not cube root both sides. You get square both sides. Square both sides. Because whenever I take a square root and square it, what happens to the square root? It gets canceled out. So I wind up with negative 2x plus 4 equals what? 4. Okay, now I can proceed to go ahead and solve for x by doing what? Subtract 4. Subtract 4. I get negative 2x equals what? 0. Divide by negative 2. X equals 0. And then we could always go in and check our answer. What's negative 2 times 0? 0. All right, so 0 plus 4 is, what's the square root of 4? 2. What's 2 minus 3? Negative 1. So do you see, I know that this question may not match up on the test, but what I do want you to learn from this is, can I get an answer? And once I have an answer, can I make sure that my answer is the answer? Yeah. Okay, by plugging it back in and see, does it get the solution that the original question asked for? Okay? And that's just a good skill to have. Number 16. Is number 16 on your list? Yes, it is. Okay. Simplify. This is a good question. We have log base 4 to the c plus 3. Now, let's see. I want to see where this question matches up with number 16. See if it's a good question for us. Or would we be better served doing a different question? Okay. We'll solve this one and then we'll do a different one. Okay? Now, what I want you to understand about these is that c plus 3, anytime I have an exponent in a log, is that I can move this out front. Okay, does that ring a bell? I know it was one lesson a long time ago, and it was one part of a lesson on logs that we probably forgot. So I would write that as c plus 3 log base 4. The next thing I want you to recognize is the log base 4. Anytime I have a log with a base the same as its number, what does it come out to? 1. So that's like saying c plus 3 times 1. What is c plus 3 times 1? C plus 3. And in most of these questions, that log base and its number are the same. So typically speaking, your answer is always going to be the exponent because the rest of it cancels out. Okay? But because, like I said, this question is similar in a sense, but not necessarily the greatest of equations. That's going to match our stuff. What we want to be able to do is we want to be able to take a question that's in exponential form and turn it into log form. So if you give me a second here, I'll try to come up with something. Let's try. Okay, that's a true statement, correct? 4 squared equals 16. All right, let's say I wanted to rewrite this in logarithmic form. What would that look like? Log. Okay, so let's start off with log. Got to have that. Okay, log base 4. Switch the 16 into 2. So what number goes next to the log but on the same line? 16. And what does log base 4 16 equal? 2. All right, so the 4 goes down, the 2 and the 16 go across. There's no exponent at that point. Okay? You're going to need to be able to do this on the test. Okay? If you can do that, you're going to be well served. Okay? Questions? Comments? Concerns? No? Okay. Number 17. Number 17. Is number 17 on your list? Yes. Okay. Number 17. All right. This is going to go into that lesson that we had on sampling. Okay. And the very specific question it's going to involve the same setup every time, which means we're going to tag a certain number of animals. Okay. Number tagged first time. Okay. Over total population. Okay. And this is number tagged, I want to say number 2. Okay, the second time, that are already tagged. Okay. And I believe this is number caught the second time. Okay, so let's look at question number 17. It says a researcher visits a park and captures 26 squirrels. Okay. Let's see. And he marks those 26 squirrels. So where do I put the 26 at? Top left, top right, bottom right. Top right, because it's the number tagged the first time. Okay, there's a reason I put this up here so that you could write that down and use it. Okay, so he catches and he tags 26 squirrels the first time. Good on you if you can catch a squirrel, let alone 26 squirrels. That's impressive. Okay, on a return visit the next week, the researcher captures 49 squirrels. 16 of them are marked. All right, so where does the 49 go? Top left, bottom right. Bottom left. Number caught the second time is 49. Okay? So then where does the 16 go? 16 of them are marked from the previous week. Top left. Okay? Number tagged on already tagged. Okay? Okay, number already tagged. Does that help? Okay? And our question is, given this, how many squirrels are in the area? Okay, that's X. So what do I do to solve this? Cross multiply and divide. What am I multiplying? 26 times 49. What am I dividing by? 16. So 49 times 26 divided by 16. Okay. Let's see. What question number is this? This is 17. What did you say your answer was? 79.65. Here's the problem. 0.25. Okay, that part doesn't really matter. Do we expect to find an eighth of a squirrel running around? Okay, because I think that's what 0.625 comes out to. Maybe it's not, but okay. So because we're dealing with something that is always a whole, no matter what decimal I get after this, it doesn't matter how small, it's always going to round up to the next whole. Okay? Because you could say that this 0.625 represents one squirrel, like represents a baby squirrel, right? It's an eighth of a squirrel. Okay? But is it still a whole squirrel? Yes. So our answer is going to be 80. Does that make sense? Okay. All right. Let's look at number 17, see how well it fits in. This one fits in perfectly with what's on the test. Different numbers, same exact formula, same exact setup. Okay? So you look to solve exactly the same way, and look for this same scenario where you're not going to, if I see a decimal point in your answer for this question on the test, it will be wrong. I'm not going to pick, oh, well, they did all the work right. No, I have a hint in the line that says, listen, it cannot be a fraction of a rabbit or a squirrel or a warthog or whatever. It's got to be a whole number. You're not going to round it down. It will always round up. Okay, I know that's contrary to how numbers usually work, right? 0.4 and down, we round down. 0.5 and up, we round up. Not whenever it comes to squirrels. All right, number 18. Is number 18 on your list? Yeah? Okay, I want to find out. Okay, I see it there. 18. Yeah, this is pretty good in terms of matching up. A gardener has 200 feet of fencing material to enclose a rectangular area of land. She wants the fenced-in area to be 2,500 square feet. The equation, W times 100 minus W equals 500 gives the width that meets these requirements. Use the discriminant to explain why these requirements can be met. Okay. So we're enclosing an area of land, correct? Okay, that's length times width equals area. Is that correct? Okay, so length times width equals area. Well, we want our area to be 2,500 square feet. Follow me so far? All right, the equation W times 100 minus W equals 2,500. So we've got W times 100 minus W equals 2,500. Okay? Gives the width that meets these requirements. Okay? Let's see. Use the discriminant to explain why these requirements can be met. So the first thing that I'm going to do is what with our W times 100 minus W? Distribute. So that's going to be 100W minus what? Minus W squared equals 2,500. What do I want to do from there? Notice that they use the word discriminant. What are you doing? Subtract 2,500. Okay, so I would get negative W squared plus 100W minus 2,500 equals 0. How many of you remember how to find a discriminant? None of us? Okay. All right, the discriminant is done using part of the quadratic formula, the part being b squared minus 4ac. Okay, so let's plug our numbers into b squared minus 4ac. Okay, what is representing b in this equation? 100. So we'd have the square root of 100 squared minus 4 times what? Negative 1 times negative 2,500. Okay, keep on going this way. Okay, so we've got the square root of 100 times 100. That's got to be what, 10,000? 10,000. Okay, well, negative 4 times negative 1 is positive 4. What's 4 times negative 2,500? Negative 10,000. All right, what's 10,000 minus 10,000? 0. So I get the square root of 0. What's the square root of 0? So we're saying that my discriminant is 0. How many solutions do you get when a discriminant is 0? How many? 1. There's one solution. One real solution. Now, let's review that for a second. What if we had gotten a positive number in there? How many solutions would I have had? 2. I would have had 2, and what type would they be? Would they have been real or imaginary or complex? 2 real or 2 complex? 2 real. What if it had been a negative number? 2 complex. Okay? So those are the 3 scenarios. Okay? Anything greater than 0 is 2 real. 0 is 1 real. Anything less than 0 is too complex. So our answer here is, since the discriminant is 0, there is one real solution to the equation W times 100 minus W equals 2500, indicating that there exists one width that meets the requirements. They're not actually asking for the width. They just want to know how many solutions for the width are there. Okay? So looking at the actual question itself that fits with this, I'm going to kind of move over here. Okay. Let's see. They're going to say that the area of a rectangle equals 224. Okay. Length is 14. Okay. The width is square root of x. It says, what is the value of x? Okay? And it says, what is the width of the rectangle? That's the question on the test. Okay? The area of a rectangle, length times width, equals 224. Okay? And I don't know how well this is going to work. I'm making up these numbers, okay? But we're giving you an example of what the question will look like. Okay? We know the length is 14. Can I substitute that in? Okay, 14. The width, okay, is radical x equals 224. Okay? What is the value of x? So what would I do with 224? Divide by what? Divide by 14. Okay, so I think this question might actually be easier. What is 224 divided by 14? What is it as a fraction? 224 over 14. Well, does it come out to 16? Oh, it comes out to 16? Well, perfect. Okay, what do I do to solve for x? Square both sides, right? Okay, so square both sides. Okay, so x equals what? 256. X equals 256. Okay, x equals 256. But keep in mind, the width is the square root of 256. Okay, so we answered the question, what is the value of x? But what is the width? What does the width equal? 16. Okay, because otherwise, if you say that the width is 256, then you're saying 14 times 256 equals 224. It doesn't, right? Okay, but what is 14 times 16? Is that 224? What's 14 times 16? Check it. Okay, so it equals on both fronts. All right, we double checked our answer. That's the question, very similar to the question on the test. Okay? All right, can you do that? Great. All right, what's up next? Number 19? 19. Is 19 on your list? Number 19. Number 19. It says use the discriminant to describe the roots. Should we be able to do this? It's just real similar to our last question, right? 9x squared plus 4 equals 3x. All right, what do I need to do here? Move the 3x. How do I move it? Subtract 3x. Okay, what's my new equation? Equals 0. What do I do with 9x squared minus 3x plus 4? How did I find the discriminant? Square root. Square root what? Negative 3 squared. Do I need to have negative 3 in parentheses? Absolutely I do. Negative 3 squared what? Minus 4 times 4. Okay? What's negative 3 squared? 9. Okay? So I've got negative 4 times 9 times 4. Should be a negative number. Negative what? Louder. Negative 135. Okay, well, that's why I would say louder, and then you guys get upset me with because I say the wrong number. It's because I can't hear you. Okay? What's 9 minus 144? Loud enough for me to hear it. Don't mumble it. Negative 135. Okay. So what it says, describe the solutions. Okay, what do I know about my solutions? How many do I have and what kind are they? 2 complex solutions. Okay, 2 complex. Because I got the square root of a negative number. All right, let's see where number 19 fits in. Number 16. Yeah, it's going to give you something similar to this. It's going to say find the number of solutions by using the discriminant, and it's going to ask you to describe them. Okay? So I actually put in the headline bar for this what your options are. It's either cannot be determined, 2 real, 2 complex, or 1 real. Okay? But you're going to have to type that. Does that make sense? Okay. All right, I think you guys can do that. Finally, what, number 20? Last question. Okay, number 20. All right. It says find a piecewise function. Is number 20 on your list? No. And I don't think that you're going to need it. Honestly, I think at this point we've covered everything that we need to cover. So in all honesty, I'm not going to do number 20. Okay? I'm going to give you, I've given you more than enough questions to look at, both questions that we want to review and questions that match up better with the test. Yes?
How do you know when the numbers are like too complex or stuff like that?
Okay, we just went over that back here. Okay? If I get square root of 0, okay, it's 1 real. Okay? If I get square root of anything greater than 0, okay, so greater than 0, it's 2 real. Okay, if I get square root of something, less than 0, let's say, okay, here, let's change that up a little bit. Square root of x equals 0, okay? This is too complex. Okay, so examples. Okay, examples of this would be, well, square root of 0. Okay, example of this would be square root of 2. Okay, example of this would be square root of negative 2. Okay? In fact, the square root of any negative number is going to be too complex, doesn't matter what it is. As soon as there's a negative there, too complex. Okay? As soon as this is positive but not 0, 2 real. As soon as this is square root of 0, 1 real. Okay? Any other questions before we close out? No? Okay. Well, I'm going to hit stop here. I'm going to get all 3 videos, hopefully I've got everything sent, and you guys can review those and be able to study for your test, quarterfinal tomorrow. Right? Great.